Hello student, this is a lecture for B.Sc. second year, semester 4th semester, and our paper is real analysis. This is real analysis second, and in last semester we have already discussed about the real analysis first. Paper number is I think it is a ninth paper. So what is ninth? Ninth is this is ninth. Okay. So dear student, without discussing or we have already discussed syllabus. Once you discuss on the topic, there is no need to discuss again and again. Okay, now I directly start our syllabus, and that is definition and existence of the interval. We are going to discuss one concept, that is the partition. Partition. What is meant by partition? Let AB be the any closed interval. This is closed interval AB. So between these, a finite set P of the points. Suppose I take this is a P, and P be the set of all point x0, x1, x2, x3 and so on to suppose xn. This is last point. And all this point lies between A and B, because this is an interval. And in between A and B there are so many numbers are there. So I can write this A less or equal to x0, less or equal to x1, less or equal to x2, less or equal to x3 and so on. Xn minus 1 less or equal to xn is equal to b. Okay. So the partition P consists of, this is a partition, and this partition P consists of n plus 1 points. This is first point, but start with 0, x0, but it is first point, second point, third point, fourth point. So this is, there is a n, so point is n plus 1 point. Okay, n plus 1 point, because in the partition P, see here partition P, x0, x1, x2, how many elements are there? There are n plus 1 number of points. So clearly any member of partition of the AB can be considered. Any member can be considered in the interval. I make some intervals for our better understanding. This is x0, this is x1, then x1, x2, x2, x3 and so on. X I minus 1, xi, this is the ith interval, then xn minus 1 and xn. So this is the first interval, second interval, third interval, fourth interval, this ith interval, and this is the nth interval. Now these all intervals are subsets of interval AB. Isn't it? Is it right? It is a subset of interval AB, no problem. This subset of all are the subsets of interval AB. So we shall use the same symbol. Delta at x or delta xi to denote the ith subinterval, to denote What is meant by delta xi? So delta xi is xi minus xi minus 1. So it is the length. It is the length of ith interval or this interval xi minus 1 xi interval. For example, suppose example AB interval is 1 to 10. This is A, this is a B, and we make some sub-interval 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 9 to 10. Then if I choose this, so delta, I take it, this is a x4, x5, so delta x5 is equal to x4 minus, x5 minus x4, so that is 5 minus 4 is equal to 1. This is the length of the interval. Now, let f be bounded real valued function. F is bounded real valued function. Now if f is bounded, meaning is that its range is bounded. So evidently f is bounded on the each sub-interval corresponding to each partition P. Then mi and small mi be the bounds, that is the supremum and infimum of the f in delta xi. So this is a capital Mi, small mi are bounds. These are bounds. Function is bounded, so these are bounds. And these bounds are called supremum and infimum. These are supremum and infimum of the f. Supremum and infimum of the f. So dear student, in 11, 12 standard we have already discussed some graphs. We know that, so this is a function, this is a graph, x-axis, y-axis, and suppose this is the interval AB. Now function is defined on this way, and suppose there is a x0 and x1 point. So on this point we get some values, we call this is the mi and this is called as the small mi. That means on this interval we get maximum value of the function is capital Mi and small value of the function is small mi. On which interval? On the interval x0 to x1. Now we discuss some sums, indications. UPF. You try to understand very carefully what is meant by UPF. So UPF is nothing but the summation I run from 1 to n capital Mi delta xi is equal to capital M1 delta x1 plus capital M2 delta x2 and so on capital Mn delta xn is called as the UPF. So what is the UPF? UPF means M1 delta x1, that means on first interval take this maximum value, that is capital M, into delta xi means difference between this. Remember, LPF, this is a sum. LP is also indicated by I run from 1 to n Mi and delta xi, this is the small m1. So m1 delta x1 plus m2 delta x2 to m and delta xn. So this UPF is called upper Darbox sum. Upper Darbox sums. This is upper Darbox sum, and this LPF is called lower Darbox BOUX sum of F corresponding to partition P. So today we discuss on the what is meant by UPF, what is meant by LPF, and what is the partition of interval for the any bounded function f. So student, today we stop it here. In next lecture we will discuss about a relationship between supremum and infimum, as well as upper Darbox sum and lower Darbox sum in the next lecture. Thank you very much.